Okay, so let's take a look at the next subtopic. Okay, stay on triple integral, but for cylindrical coordinates. So when we're going to use on cylindrical coordinates is when region R, the projection of G is in circular type shape. Okay, so in this cylindrical coordinates, we have three types. Okay, when the projection on XY plane. Okay, so let's take a look at this one. Okay, previously on polar coordinates, we learned that x equal to r cos theta, right? So y equal to r sine theta, and x squared plus y squared equal to r. Okay, so if the projection is on xy plane, so x still equal to r cos theta, y equal to r sin theta, but z remain as z here. So we have x squared plus y squared equal to r squared. So for dA here, we remain use on r dr d theta. This one is not changing. Is same for all three types. Okay, but let's take a look on the second one. If the projection of G is on xz plane, so here x will be r cos theta, but z is equal to r sin theta, and y remain as y. So here also change, x squared plus z squared equal to r squared. And if on the third types, if the projection R, projection of G on yz plane, so here y will be r cos theta and z equal to r sin theta. So x remain as x, so here y squared plus z squared equal to r. Okay, so please remember for cylindrical coordinates, okay, basically it's just reflection on polar coordinates that you have learned in double integral. Okay, so if the projection is on xy plane, z will remain as z. If the projection is on xz plane, y will remain as y. And if the projection is on yz plane, x will remain as x. Okay, and dA will always be r dr d theta here. Okay, so let's take a look at the third step is usual. So we just will determine the limits. Okay, so we're gonna use all the knowledge that you have learned in polar coordinates from double integral. Okay, so for sphere also can use spherical coordinates for convenience, since we have also the top, okay, no, the bottom will be the in spherical shapes too. So that's why we can also use spherical coordinates for sphere. Okay, so let's take a look at the sketching. So on xy plane, so we convert, right, on x and y in terms of r and theta. So if on z here, so the point will be r, theta, and z. So z remain as z here. Okay, so let's take a look at the first example. So use cylindrical coordinates to evaluate this one. Okay, so the first thing first, you have to know what kind of solid that you get from the limit given. Okay, so if we take a look on this one, so let's clean this one first. Okay, so from here, so we have z. Okay, we are okay. So from the question, we have z equal to 9 minus x squared minus y squared. Okay, so basically if you sketch using GeoGebra, so you're gonna get this shape basically. Okay, paraboloid. Okay, this one. Okay, so if we take a look on x, so it's 3 up to 3, right? Okay, so x on xy plane, so basically this shape is meshed with the limits given here. Okay, so if we portray on the 2D plane, okay, here, so this is basically the bottom. Okay, so the bottom in on xy, right? So dy dx here, so we're gonna use this one. Okay, the first one. Okay, so r equal to r cos theta, y equal to r sin theta, and z remain as z here. Okay, so after you got the shape, okay, so we're going to decide the bottom. Okay, so the bottom on x and y, right? Okay, so this one is 3, this one also 3, this one -3, this one -3. Okay, so this circle, okay, the equation for this circle basically x squared plus y squared equal to 9. Okay, so after you got this one, so we're gonna convert into cylindrical coordinates. Okay, so x here, so since we use type 1, right, so x in this case equal to r cos theta. That's why we have r squared cos squared theta here. So r dz dr d theta. Okay, r dz dr d theta here. Okay, so how to get the limit for the r? Okay, so the radius is 3, right? So that's why we have 0 up to 3 here. For theta, so we consider the whole circle, right? So that's why we have here 0 up to 2 pi. Okay, so after that we can integrate as usual, so you will get the answer. Okay, so basically the difference between polar coordinates and spherical coordinates basically the addition of z here. Okay, so from the question given, you have to decide basically projection on which plane, either on xy plane, z plane, or yz plane. So in this case, is obviously on xy plane. So that's why we choose type 1. Okay, you need to get the whole shape and also the bottom shape. Okay, the bottom limit, so that you'll be able to convert it into spherical coordinates. Okay, so I'll give you another 2 questions. You can try to get the shape first, okay, the solid region first, and then you can try to answer this question. Okay, I will share the answer later in the WhatsApp group. Okay, so same goes to the application. Okay, so if the application of Cartesian coordinate is equal to volume, so same goes to cylindrical as long as the function given is 1. Okay, so that's all. Thank you.